Hey folks, David here. Just turned on my camera. Going to start in just a minute. Let me get everything set up here. Right. Just checking a couple things. All right, cool. I am going to go ahead and get started. So what I'm doing, I recently came across, I have a link here, a set of tips for data cleaning in Excel. I'll actually just pop the PDF over here. This is from the Western Michigan Evaluation Center. I forget the exact name. But I thought it might be useful because a lot of the folks that I work with are coming from Excel. And I thought it might be useful to kind of show some equivalence when it comes to these data cleaning tips in R. These tips are really, I don't think they're intended to be kind of comprehensive in any way. They're really just, to show some ideas for ways you might do some data cleaning. I'm recording this now live. I'll also be putting this together as a blog post, and I'll post some links to some more comprehensive sources that have information about how to do data cleaning in R. But for right now, I'm just going to go ahead and basically they got 5 tips here, and I'm going to take each of these and show you how you would do them the same thing in R. So I'm going to copy this here. Let me put this back here. And I'm just going to make each of the items that they have into headers. I'm obviously working in an R Markdown document here. I've just called it Excel Data Cleaning Tips in R. So the first thing I'm going to do, they talk about identifying all cells that contain a specific word or short phrase in a column with open-ended text. So let me scroll down here. The way that they suggest doing this in Excel, if you want to kind of highlight some of these, I'm not really clear, to be honest, why this exactly is data cleaning, but I'll leave that. Anyway, so they have, for example, some sample data here. It's got 3 lines. I love Excel for data. Data cleaning is great, and this is fun. And then they suggest some steps here that you can use on Excel to highlight those. So let me go ahead, first of all, and just make a data frame with this text. I don't actually know if this is going to work. I'll just call this text data. And I am going to make this what's called a tribble. I don't do this super often, so whoops. I'll just call the first column response. It doesn't actually work to copy it in, so I'll just type it. I'll type, I love Excel for data. Data cleaning is great. And this is fun. Let me run that. Oh, duh. A couple of reasons this is not going to work. First of all, I haven't loaded any packages, so let me load tidyverse. And then obviously I'm also typing code outside of a code chunk, so that's obviously not going to work either. Let me pull this over here. All right, let me try this again. So now I have text data, and you can see I just have 3 observations, 1 variable, the response variable. triple is just a nice way to easily input data, and that's how I'm going to work today. I'm not actually working with any kind of actual data set. I'm just going to work with the kind of short snippets of data that they suggest using. So let me actually make a new code chunk. So if I wanted to identify words or specific phrases in a column with open-ended text, for that I would use the stringr package, which is part of the tidyverse. So you know, for example, down here, you can actually see all the packages that are being attached or being loaded when I use library tidyverse. You can see the same thing here. And stringr is one of them. So I'm going to use actually what I'll do is I'll just make a new variable. And I'll do that by using the mutate function. So I'll call my new variable contains data because I'm going to make a dichotomous variable, yes, no, that's whether or not a certain phrase or word or phrase in this case is contained in another column. So contains data, and I'm going to have that equal to, and I'm going to use the case when function. It's basically a kind of more, it's a way to do kind of nested if-else statements. I find it, I just use it for everything because I find it much easier than if-else. And actually, sorry, just to interrupt myself, if you have any comments and want to put them in the chat, either on Twitter, or on Twitch or on YouTube, I will get them out. If you see me looking over the screen, that's what I'm doing. I'd love any questions. And specifically when I get to the section dealing with dates, I am not very good with dates, so feel free to offer me some help. All right, so back to this, contains data. So they suggest in Excel, highlighting data using the steps outlined here. Obviously, there's no kind of highlighting in R. So again, we're going to make a new variable. So I'm going to use the case when, which will say basically if something, then do this, else if something else, then do that. So I'm going to say case when, and I'm going to use the STR Detect function. That's the function that comes from the stringr package. I'm using that because I'm going to look for this phrase data, and I'm going to look for it at any point in the column. So I'm going to say STR Detect, and I have to tell it which column I'm looking for. So I'm going to use the response column, data, and I'm going to say if you find this phrase, the second argument here, this data, is saying if you find that phrase, data, then mark the contains data variable true, or sorry, yes, true, which is to say if there is text in that column, in that response column, then mark it no. So in other words, if it's not NA, which isn't applicable because we have 3 responses here. We don't have any NAs. So let me go ahead and run that. You can see now I have response and I have contains data, and it has yes for the first one, has no for the second one. We'll talk about that in just a second. Has no for the third one. Obviously, this is fun, has no text called data. So we want that to be no. But we would probably like data cleaning is great. So the capitalized data to be marked yes. So there are a couple of ways I think about doing that. Let me actually look at the help for STR Detect. I think there is a fancy way that I could do it with telling it to ignore case. I don't actually know what it is off the top of my head, so I'd have to look into it. I thought it might be in the help section, but it's not. So I'm going to actually just do this. I'm just going to say if it's lowercase data, then mark it yes. If it's uppercase data, then mark it yes. Otherwise, mark it no. So you can see now I have the first 2 being yes. A perhaps slightly more elegant way would be this. I could do response lowercase equals, there's a function str to lower, which, as the name implies, takes your entire text from whatever other variable and makes it all lowercase. So for example, if I do that, you can see now I have a new variable where everything is lowercase. So now, if I took that, I could change this to lowercase. And actually, if I do that, then I can delete this here, because I'm only looking in this variable, and I know I have only lowercase datas. So you can see I have that. Okay. So I'm not actually assigning this, just to be clear. I'm not making any new data frame. All I'm doing is displaying the results down here. But if I wanted to, I could, for example, do text data clean and just assign it like that. And now I have a new data frame here, text data clean. Okay. But I'm actually just going to leave it like that. Because I'm going to, when I display this code in the blog post that I put together, I actually want it to be just like this. All right, let me go to the second one. Identify and remove duplicate data. So let's see what they got here. Oh, thank you. CZ Turner on YouTube. Using square brackets around the letter D might remove the need to determine the case. Cool, let me try that. As I think you saw, I'm not super great with, I don't even know if I'm pronouncing it right, regex, regular expressions. So let me try this. So I'm commenting out that line. Here, I'll actually just copy this in here. So the comment that came in on YouTube said that using square brackets around the letter D might help. So let me try this, see what happens. No, that didn't work, but CZ Turner, if you have feedback, maybe I'm not doing it exactly the way you meant for me to do it. So I'd love to know more because it would help me to learn something. I'm going to move on, but if you want to type something else, I will keep an eye on that. So in terms of identifying and removing duplicate data, so let's see, they have a very simple set of data here. So for example, they have Joe Smith twice. Let me do this. So I'm going to make, I'll just call it names data, and I'll do tribble. Let's see, so it looks like it has a first name and a last name. So I'll do Joe Smith, and then I'm just going to add Joe Jones. You can see they have kind of an example here. So names data, you can see what I ended up with. First, last. Yeah, so let's work on eliminating duplicates. Let's see. Close these other ones. So there are a couple ways that immediately spring to my mind, and again, if you have feedback, let me know how you handle this. I use the distinct function a lot. I'm just trying to remember if you can do this on multiple variables. I think you can, yeah. So what I might do is this, names data distinct, and the first, well, the first argument is the data, obviously, but because I'm using the tidyverse and I'm piping this in, I don't have to put my data here. So now I just have to give it the variable names. Yeah. So if I do that, let me see. Perfect. Now I've ended up with, I said distinct first last. So what it's done is it's looked for distinct observations of cases where you have a unique first and last. So for example, it dropped if you're 1. The other way, I'm going to load another package. I'll just put it up here because I like to load all my packages at the top. The janitor package. look at this. Let me pop. I'm just doing it in a browser because I really like the package down format. So the janitor package has a get dupes function, which enables you to identify where there are duplicates. Okay, cool. I can move that out of the way. So you could do names data, get dupes, and I think I could do first and last. Yeah. Yeah, so what it's done is it's returned observations where there are duplicates. It's kind of the opposite. You'd then have to like do some work with this if you wanted to eliminate them. So I mean, probably this is going to be more straightforward. But there are cases I can imagine where you might want to like see what are the duplicates in order to then do things with those later on. All right, let's move on to the next one. So identify outliers within a data set. So they suggest using data validation, but I'm going to try and do this in a... well, just to take a step back, if you haven't used data validation, it basically allows you to give error messages to people when they try to enter things. And it's a way working within Excel that you can kind of hopefully try to stop some of that those data issues before you actually get the data. Obviously, there are cases where you get data that you don't that doesn't fit what you want, so you're going to need to clean it. So let's talk about cleaning. For example, they want 2019 dates. So I'm going to do. I'll just call this dates. And I will make this tribble. I'll call the column date. And I'm going to put it in exactly as they do. So 3/21/2018, 4/3/2019, 11/26/2019, and 5/6/2018. All right. So I got my dates here. Okay, cool. Now what they're doing here is basically saying, in this case, our outliers. I know this is a very simple way of looking at outliers, but let's just roll with it. Their outliers in this case are they only want to include 2019 dates. So looking at my dates dates data frame, I could. Oops, no, I don't actually want to do that. If I look at the date variable, I can see it's actually a character variable, even though a human looking at that would understand that those are dates. R does not yet understand that. So in a very simple way, I could actually just keep those as character variables if I wanted to. If all I wanted to do was drop 2018 observations, I think I could actually just use mutate, I'm thinking about using like STR Detect, but there's a negate option. No, actually, hold on. I'm going to use filter, and I could use STR Detect on date, and say basically if you find, yeah, there we go. That's as simple as that. If you find the phrase 2019, then keep it. So a lot of times you'll do filter like year equals 2019, something like that, or date, I guess, in this, something like that. But because 2019 shows up at the end, we would use that STR Detect. So that's like the simplest way. You could also then, if you wanted to convert them into actual dates, you would use the Lubridate package, and this is the one that I am not so great with, so let's see how I do with this. So I need to first parse the date variable so to make R understand that it is a date. So I need to look at the way it's formatted. There are a series of functions. So I'm going to use DMY, I think, which is date, month, year. No. Oh, what am I doing? So I'll say mutate date equals DMY date. Yeah, that did not work. Hold on, let me look at, because two of them, as you can see, failed to parse. Let's see. As you can see, I don't actually work with dates a ton. I thought date, month, year would work. Let's see. Run that again. I'm trying to figure out the pattern as to why it's only returning certain dates. So it didn't return that one and that one. Huh. I am struggling because clearly I don't work with dates very much. I might actually skip this for now since we have a solution based on a simple solution based on just treating it as characters. Maybe come back to that later. Let me do the next one, which is separating data from a single column into two or more variables. So for example, they talk about, if you get, say, names, wanting to separate those into first name and last name as an example. So let me make a new data frame. I'll just call this names data 2. And I'll make this a trivial name, Dottie Smith, Harold Vicker, and Gloria Perez. Let me open up names data 2. All right, cool. So the way we're going to do this, in Excel, they talk about using the flash fill function, which to be honest, I've never actually used. In R, we can do names data 2. And then we can use the separate function. What that does is it allows us to separate a single column into multiple. So I will say separate the name column, and then you have to tell it what the separator is. And in this case, it's just a blank space. Oh, wait. Sorry, I forgot an argument, which is into. We have to tell it what are the names. Let me actually make sure I'm getting this right. Separate. Yeah, so I have to give it the names of my new variables. So I'll do C first and then last. Yeah. So now I've said take the name variable, separate it into a first and a last using the separator, which is a blank space, and you can see now I have a first and a last name. Okay. That was relatively straightforward. So now we're going to categorize data in a column. So essentially this is recategorizing. So let me take, I'll call this agreement data. Again, I'm going to make a tribble, just call it response, and they have agree, strongly disagree, strongly agree, disagree, 2 agrees, 2 disagrees, a strongly disagree, and agree. Oh, cool. I got a response about the date. Thank you, CZ Eternal. I will actually go back to that in a minute. All right, cool. So let me just pop this up here. All right. So what they're talking about is, say you want to recategorize your data into, kind of, in this case, positive and negative sentiments. So we can do this using the mutate and case when that we used above. And basically what they're saying is if someone says agree or strongly agree, let's make that positive. If someone says disagree, then let's make that, then we'll make it negative. Sorry, I was just thinking as I was talking. So I'll just make a new, actually I'll make it, I'll just call it positive, negative, equals case when, and I'm going to say if response, and I'm going to use the in operator. So basically, if the response is agree or strongly agree, then we'll make it positive. I'm just going to copy this. And if it's disagree or strongly disagree, then let's make that negative. So you can see now when I run this, agree is recategorized as positive, strongly disagree is recategorized as negative. Everything is recategorized in this way. And I think just to kind of talk about why you might want to do this in R, not Excel, one of the major benefits is that, anytime you would get new data, if you were doing a survey or something like that, you can just rerun this code and it'll automatically recategorize your entire data frame, which is really convenient. As opposed to if you're doing it manually in Excel. I know there are ways to do it with formulas that make it less manual, but it makes it just a lot more laborious if you're doing it in Excel. Cool. Let me go back up and see if I can figure out stuff with the Lubridate package. So I'm going to try, the feedback here was to try the MDY function. So I'm going to say date equals MDY date. Ah, thank you. That worked perfectly. I don't know why month, date, year. Oh, yeah, I think I just had it backwards. Yes, I did. All right, so now what we could do, there are a few ways we could handle this. I think the simplest way is, because it's now a date object, we can just parse the year using the year function. So actually, I probably shouldn't be using like the name date for my variable and year for my variable name because there are also functions called that. So I'll just call it ops year. Actually, let me spell that out. Observation year. And that's going to be equal to year of date. So you can see when I do that now, this year function gets the year of the date here. So once I have that, I can now just use a simple filter to say filter so that observation year equals 2019, and you can see now it only keeps those. Cool. So we made it all the way through these 5 tips. I hope that's helpful. If folks have feedback or questions, I'd love to hear it. I'm going to turn the live stream off, but let me know on Twitter or email david@artfortherestofus.com. Thanks, everybody.